Today is the day that we take a lot of the stuff we've talked about the last couple weeks and kind of put it all together. Okay? We've talked about finding asymptotes. We've talked about finding both horizontal and vertical. We've talked about finding points of discontinuity. Okay? Today we're going to use that stuff to actually find the graph. Okay? So just as a reminder, I know it says how right here, so steps for graphing rational functions. It says how. We're going to use these boxes as reminders to ourselves. Not to write the whole exact of way to find it, but this is what we've been working on it. So we're just going to give ourselves reminders in this box right over here of how we get to those things. Okay? So what's our reminder going to be for locating the vertical asymptotes? Set denominator. What? Equal to 0. Good. What's going to be our hint to ourselves if we're trying to find the horizontal asymptotes? Look at degrees. What about points of discontinuity? In order to find those, what do we have to do very first? Factor. That's exactly right. And then we remember that it's going to be a point of discontinuity if it occurs in the numerator and in the denominator, right? The same factor. Okay. Then we want to draw the asymptotes with dotted lines. Why would we draw asymptotes with dotted lines and not just actual lines? Do they exist? No. Right? They're a place on a graph that nothing can exist, right? For the most part. Okay. Then we want to make a table of important values, and I think you'll understand what I mean about important values here in a moment. We're going to plot the points and sketch the graph, and then we're going to identify the domain and range. Now, somebody told me the other day those words don't scare them as much as they used to. How do you feel about that statement? Do you agree with that or not? Yes? After the project? Yes? Okay. So look through these problems. 1, 2, 3, 4, 5. You think we can get 5 problems done in one class period? I hope we can. Where do you want to start? Your choice. I see 1 vote for problem number 1. I see 1 vote for problem number 5. 1 vote for problem number 2. What do you want to start with? 5? Okay, I actually see more votes for 5. Sorry. Not everybody was voting, though, so that's their own fault. If you don't vote, you can't speak. I'm sorry. Well, hopefully we'll get to number 1. Are you going to be okay? Okay, so when all we're doing is looking at this problem, which one of these 3, either vertical asymptote, horizontal asymptote, or point of discontinuity, which one of those is easiest to see first? Yeah, a lot of people think horizontal is easiest to see first because you're just looking at the degrees. 2 and 3. What do you notice? Between 2 and 3, 3 is bigger, right? Where is 3? In the denominator. When the degree of the denominator is greater, y equals 0. Now, did you remember that off the top of your head? What did you do? You looked at your paper. You looked back at your notes. That's a perfect idea. Pretty much the only day you can't do that is when? On the test. Okay? Up until then, you're giving yourselves a reminder. You're giving your brain a reminder. So horizontal asymptote we have at y equals 0. Okay? How do we find vertical asymptotes or points of discontinuity? I really need to. Before I can set the denominator equal to 0, what do I kind of need to do? Factor. That's exactly right. I need to factor it. So let's go ahead and factor the numerator. Trinomial, there's not a greatest common factor there. So I can look and say AC is negative 6, B is 1. So what multiplies to be negative 6 and adds to be positive 1? What kind? X minus 2, x plus 3. So that's my numerator, right? Now in the denominator, I have, oh wow, I have a trinomial, but notice I have a greatest common factor, don't I? What is that greatest common factor? X. So if I factor an x out, think of each one of these as having 1 less x. So that one doesn't have one, right? So it's in the typical form we're used to. So we can go ahead and do AC and B. AC is negative 10, B is 3. Multiplies to be negative 10, adds to be 3. Good. X minus 2, x plus 5. So, I see this. What does that tell me? That's going to tell me my point of discontinuity, isn't it? So, here's the deal though. By implying that I have a point of discontinuity, how do I have to write my answer? As a point, right? As a point. So my point, what's the x value of my point? Absolutely, it's a 2. I set that equal to 0 to get the x value of my point. How in the world do I get the y value? Because if I plug it into this equation right here, I'm just going to get 0 over 0, aren't I? Well, I have to pretend that that is not there. Now plug it in. What's 2 plus 3? Wait, why am I pretending that's not there? Because if I was simplifying, what would happen with those two factors? They would cancel to 1, wouldn't they? And so that's going to make it safe for me to find my y value. So now, 2 plus 3. 5. What is 2 plus 5? 7 times 2? Yes, sir?
You and Jason have to.
Yes, I do.
Could she come off, please? She's leaving.
Yes, I will send her.
Thank you.
Okay, back here. We did 2 plus 3 and we got 5. We did 2 plus 5 and got 7 times 2 is 14. So what? Do you want to do the math? We kind of need to, don't we, if we're going to be able to find it? What's 5 divided by 14? .35? Is it exactly 0.35? So it's exactly like that, or we're still approximating? Okay, that's okay. We just have to keep that in mind. We're still approximating right there. Okay? What about vertical asymptote or asymptotes? How do we find those? Aren't those all the rest of the factors in the denominator that I didn't use? Wait, even this one? Yeah, set it equal to 0. So that's one of them. Ooh, I'm going to have 2. Very good, negative 5. So x equals 0 and x equals negative 5. Now at this point, it's probably a good idea to head over to our graph. Okay, let's head over to our graph. How do I graph the vertical asymptote x equals 0? If it's crossing the x-axis at 0, isn't it right here? Isn't it the y-axis? Okay, and then if I have x equals negative 5, that's crossing the x-axis at negative 5. So that's right there, isn't it? Okay. Now I have a horizontal asymptote at y equals 0. If it's crossing the y-axis at 0, that's better known as the x-axis. Yeah. Okay. Now, I also have a point of discontinuity at 2, 0.35. So like, oh, look at the scale, by the way. Okay, it's not just like 1, 2, 3. So if that's 0.8, then that's 0.4, so it's right below that. Like right there. Is that right? Okay. Now, do I know what my graph looks like yet? No, but I have some ideas of where it's not, don't I? According to the asymptotes. Okay. Now we have to choose important values, right? Isn't that what it said? Make a table of important values. Well, what kind of important values are we going to have here? What two x values do I definitely want on my table? Yeah, 0 and -5, right? I don't want those right next to each other. I kind of want stuff maybe in between, maybe on either side, just to kind of give me an idea of what my graph looks like, don't I? So maybe for sure -6, -5, -4. But I only have room for 7, so I can't just go -3, -2, -1, 0, because I don't have anything on the other side of 0. So is it okay to skip around on the table? Yeah. So how about -1, 0, 1, and 2? Hey, let's add another one. Let's think outside the box. Okay. So how do I figure out what my table looks like? What am I going to do? What would be your first reaction to try? Yeah, your calculator, right? With the graph function. What I don't want you to do is hit the graph and just kind of sketch what you have on the calculator on the graph. I definitely don't want you to do that. Okay, I actually want you to go find these values for the table first. Okay, so I'm going to press in a fraction. Babe, if you need to go, I'm making a video for you right now, so it's okay. So I'm going to make a fraction, and I'm going to say x squared plus x minus 6 over x raised to the third plus 3x squared minus 10x. Now I'm going to see what the graph looks like. Now I have some weird sort of window on my screen, so that's kind of nice because I actually can't see what the graph looks like, right? So I'm going to go to Control T. I'm going to go find the values I need on my table calculator for my table. But guys, where are these values coming from? If I look on my table right now and I see 0 is undefined, how do I know that already? Because I have an asymptote there, don't I? What else can I automatically fill in even before I look at the calculator? -5, it's undefined. How am I going to find out what 1 is? Mathematically. I know we're going to use the calculator, but you know how I feel about the calculator. If we understand the math, we can use the calculator, right? So what's happening? What am I doing with this 1? Yeah, I'm plugging it in. What's 1 squared? 1 plus 1? 2 minus 6? -4. 1 cubed plus 3 times 1 squared is 3, so plus the 1 is 4, minus 10. -6. So I have -4 divided by -6. That's 2/3, right? Hey, look what I got on my calculator. 0.6 repeating. Guess what that is? You know, it's 2/3, right? So you understand what's happening here. I can't let you use the calculator unless you understand what's happening. So do you understand what's happening? Okay. So -6 then is going to be -0.5. -4 is going to be 0.25. Is that saying negative, or is that just a mark on my calculator? Okay. Let's see. -1 is -0.5. 2 is also undefined. Did I know that already? I did, didn't I? Right? There's a point of discontinuity there. So we could have already filled in that as well. 0.25. Thank you. So let's plot these points. Negative 6 is 0.5, which is right there-ish. Negative 5 is undefined, I know that. Negative 4 is 0.25, which is right there-ish. Negative 1 is 0.5, or negative 0.5, so down here-ish. Oh, negative 1. What am I doing? Sorry about that. Ignore that one. 1 is 2/3, so 0.6 repeating. 2 is undefined, I knew that already. And 3 is 0.25, so like that. That doesn't look like anything, does it? Usually when we plot points, it gives us a nice line or a nice parabola, right? Look back real quick. I'm sure you guys have a nice window, don't you? Menu. I'm going to change my window to be a standard window real fast so we can look at this. What did I do? Right here? Oh, thank you. No, that's fine. Thank you. So down here? Good catch. So remember, rational functions have all these curvy thingers, right? So this is really telling me it's going to go like that. This one, like that. And be careful on this one, because what happens when I get to this, the hole? I got to stop, right? I don't fill it in, and then I go. What about my domain? You said you're feeling better about domain since we did the project, so tell me how far left does this go? Forever. Then as we're coming to the right, what happens right here? In my asymptote. It stops, doesn't it? And then it starts again up here, and it's coming down, and then it stops again at 0. And then it's coming in, except it stops at 2, and then it goes on. So a couple different ways we can write this, and I need you to really kind of know both different ways. First of all, we can really say it's all real numbers except x is not equal to what? Negative 5, 0, and 2. That's absolutely right. I'm going to show you the other way on one of these other problems that we do that's not quite as messy. Okay? It's not hard, it's just messy. What about the range? How far down does it go? Forever. And then what happens right here? It stops, right? Wait a second. I thought we said you can't cross asymptotes. There's a hole right there? No. Remember what I said is you can't cross vertical asymptotes. There are times we can cross horizontal asymptotes, and this is an example of one of those times. The asymptote is really for this end and for this end, not so much in the middle. Does that make sense? Yes? Good. So, but regardless, right here and right here, it is truly an asymptote, like what we're used to, right? So nothing can exist right there. So as we're coming up, how do we write that range then? What do you think? Should we say all real numbers except for 0? But what happens? What's happening right here? It's allowed to be 0, isn't it? So how do we say the range for this one? All real numbers. Will there be a time, like if this part wasn't here and it was just these outside parts, would I say all real numbers except y does not equal 0? Yeah, absolutely. Okay? Because it doesn't have this middle part. And you'll be able to tell that by your graph. Okay? Any questions so far? So that's one whole problem done. Should we do number 4? Yes? Okay. I'm not going to do both of the hard ones. You're going to have to do one of them. Pansies. All right, look at number 4. What do you need? I'm recording. What do we want to do first? You want to factor first? Okay, we can do that. So what do we do to factor the numerator? Yeah, you're right. It's already factored. Yeah. So what do we do for the denominator? It's the difference of squares. How do we factor the difference of squares? Remember, it looks like that. What goes in there? Both square roots. What about the signs? Yep, they're opposite. So, what can you tell me? We don't have to go in order. I know some of you like to go in order. We don't have to. In fact, we didn't on the last one, did we? We found the horizontal asymptote first. Wait, what'd you say? Yeah, what'd you say? There's not a horizontal asymptote? Why? So if we look at the degrees, the degree is 1 and the degree is 2. So the degree of the denominator is greater. Oh, y equals 0. Okay, y equals 0. That's a horizontal asymptote. Then what? So if we're going to try to find the point of discontinuity, that occurs when there is a factor in the denominator that is the same as the factor in the numerator. There's not one, is there? So what do I write? None. So what about vertical asymptotes? How do we find vertical asymptotes? Set the denominator equal to 0. So x minus 3 equals 0. X plus 3 equals 0. So x equals 3. X equals negative 3. So again, we have 2. Okay. X equals 3. X equals negative 3. What do you want to do next? Domain and range, the table, or the graph? So we kind of have to go back and forth if we're going to do the graph. We got to go back and forth between the graph and the table, don't we? We can go ahead and plot our asymptotes if we want. One at negative 3 and one at positive 3. And we have our horizontal asymptote at 0, y equals 0. So again, that's better known as the x-axis. And we don't have a point of discontinuity this time. So in order to find out what our actual graph looks like, what do we want to do? Yeah, we need to fill in the table, right? Okay. So we want 3 and negative 3 like in the middle of our graph somewhere. We want values on either side of it. So maybe negative 4, negative 3, negative 2. And if we do 2, 3, 4, that leaves us 1 in the middle. Let's go and do 0 just for fun. Because zeros are fun. So what are you doing right now? Entering it in your calculator? Okay. Entering the equation. So in the numerator, we have 4x. In the denominator, we have x squared minus 9. So does yours look similar to mine? Are we on the right track on our graph? Is there an asymptote right here, an asymptote right here? Yeah? Okay. So let's look Control T. I don't want to immediately transfer that because I want some good values to transfer, right? So let's look at negative 4. Negative 4 is negative 2.3, let's say. Negative 3, I could have already filled in that was undefined, right? What else could I already fill in as undefined? Positive 3. Okay. Negative 2 is 1.6. 0 is 0. 2 is negative 1.6. And 4 is 2.3-ish. So let's plot those points. Negative 4, negative 2.3. I went the right way this time, right? Okay. And then undefined, and then negative 2, 1.6, 0, 0, positive 2, negative 1.6, 3 is undefined, and 4 is 2.3. Now once again, here's a thing that happens sometimes, and I want you to be careful of, okay? These 3 points right here, what do they look like? To me, they look like a line. So can I just connect them nice and straight? Or do I know better? I know better, right? I'm going to say Control T to get that table away for just a second. I know it's curved. Whoa, what I wrote on my calculator. I know it's curvish right there. So when I draw this, I need it to make sure to be curvish. I also know that this is coming like this. I know that this is coming like this. Okay? What about domain and range? How far to the left is it going? All the way? How far to the right is it going? All the way, but what's happening in the middle? So all real numbers, x is not equal to what? And 3. And what about my range? Why is it all real when I have an asymptote? Because of that middle section, right? Because of that middle section. I will do one more for you. Fair? Oh, I mean more than fair because I'm doing your work for you. Oh yeah, more than fair. Okay? I'm going to do number 3. Jerk. What do we want to do first? Factor it? Okay, go ahead. Okay, done. Oh yeah, that was good. Alright, so vertical asymptotes, horizontal asymptotes, point of discontinuity. Why is there no point of discontinuity? It doesn't have the same factor top and bottom. That's perfect. Okay? Only thing I would change if I was going to change anything about that sentence is numerator and denominator instead of top and bottom. But I know you know what you're talking about. Okay? So, none. So if we know there's no point of discontinuity, is there any vertical asymptotes? Where? X minus 3 equals 0, so x equals 3. X equals 3. What about horizontal asymptotes? What's the degree of the top? So 0. What's the degree of the bottom? 1. So that means the degree of the bottom is, the denominator is greater. So y equals 0. What do you want to do now? What you got? No, but still y equals 0. Horizontal have to go this way on the graph. That means it's going to be crossing the y-axis. Okay? So we'll go ahead and draw that horizontal asymptote in. Y equals 0, also known as the x-axis. I have a vertical asymptote at x equals 3. So it's crossing the x-axis at 3. What about my table? What do I want in the middle of my table? 3. And I already know it's undefined, right? So 2, 1, 0, 4, 5, 6. Will that work for you? Okay. So on my calculator, I'm going to delete this previous problem, and I'm going to make myself a fraction. Negative 4 over x minus 3. I'm going to go look at my table so I can get my values to plot. 0 is 1.3 repeating. 1 is 2. 2 is 4. 4 is negative 4. And negative 2 and negative 1.3 repeating. So 0 is 1.3, so 1 1/3. 1 is 2. 2 is 4. 3 is undefined. 4 is negative 4. 5 is negative 2. And 6 is negative 1 1/3. So again, knowing what we know about rational functions, we know these are curves. So we know... What else do we know? Can I draw this like this? Can just like that? Like this? Look. Why not? Because we're not going to cross that, are we? Okay. Wait, is this one of the places it can cross the horizontal asymptote? No. So what about our domain? I'm going to show you the other way this time. We've already talked about it at the beginning of the year. I need to remind you. How far to the left does it go? All the way, and then it stops at 3, but it starts again right on the other side of 3 and goes on to infinity, right? So it goes from negative infinity to positive 3. 3 is not included, so I have to have a parentheses instead of a bracket. And then that sign means union. It means and. On the other side of 3, not including 3, it starts again and goes to infinity. Remember when we talked about that? It's been a while. And you already know the other way. All real numbers, x is not equal to 3. What about the range? From negative infinity to where? 0, it stops at 0, and then it starts on the other side of 0 and goes to infinity. Exactly right. What's the other way? All real? Y is not equal to 0. Excellent. Okay? So you guys have number 1 and number 2 to do. Okay? Number 1 and number 2 to do. Come see me if you have any questions.